Welcome to the podcast. Today, we're diving into the technical details of zero gravity. We're going to have each of the guests introduce themselves. So say your full name and your role at Zero Gravity, and then we're just going to dive directly into the questions. So Ming, let me hand it off to you.
Hello, everyone. I'm Ming, and I'm the CTO and co-founder of 0G. And before joining the Web3 area, I was working in the Microsoft Research Asia for 11 years. And my major research direction is the distributed system. So including all the storage, computation, and also the large-scale AI platform. And later on, I co-founded another blockchain project called the Conflux. And it is a highly efficient layer one blockchain, and that's where I accumulate a lot of experience on building the blockchain infrastructure. And recently, I met with our co-founders in the of 0G, and we discussed some new ideas, bigger scenarios to build a best team in the world, so that we come up with this 0G idea and the new project. Yeah.
Amazing. Michelle, quick intro, and then we'll get on to your role.
Hi, my name is Michelle Tian. Super excited to be here. I lead the product efforts at 0G. Before this, I was at Avalanche for 2.5 years, leading the interoperability efforts. And then before that, at 21 Shares and Morgan Stanley.
Perfect. And last but not least, Lachlan.
Hey, thanks for having me. My name is Lachlan. I do technical content with Zero Gravity. And I come from a background where I did my master's in big data and analytics, and then worked on a lot of different technical content across Ethereum and Cosmos projects. So excited to be here.
Awesome. And I am your host, Jax. So real quick, let's talk with Ming a little bit about, can you give us an overview of 0G? What is the mission of the project?
Sure. So 0G is going to provide a large-scale capability to, for example, the data solution for the AI applications. So to make AI public good, and we want to decentralize and democratize any part of the AI workflow by using the crypto technologies. And currently, 0G provide a decentralized storage and decentralized DA network, and we're also building the stack layer up that we are also building a serving network, which include the decentralized computation resources for the AI. So to make the AI get into this Web3 area, we think that we can provide more privacy and transparency, and also fairness to the AI workflow, and really make this AI public good. And in this sense, actually, we are essentially building a operating system for the AI computing system, for the AI computation workflow, and so that we can easily adapt any AI applications and platforms from the Web2 area, get into this Web3 scenario.
And for people that are relatively new to this space, let's say they're crypto natives or they're just starting to get into decentralized AI, let's talk a little bit about, is there an analogy we could give them to kind of demonstrate the value that Zero Gravity or 0G is bringing to the ecosystem?
Yes, just as I mentioned. So basically, we essentially build a fully decentralized AI operating system for the AI workloads. And this is a good analogy. So basically, operating system, everyone knows that. So in our desktop PC computer, and the operating system is used to manage the hardware and hardware resources for the application softwares, and provide interfaces for the easy development of the software applications on top of that. And in this decentralized scenario, we have all kinds of hardware resources like storage and computation resources join this system in a permissionless way, so that it really needs a infrastructure software to help the application builders to manage all these manage and coordinate all these hardware resources better for them to use these kind of resources in a very efficient way, and also allow the to provide interfaces to allow the easy development of all these kind of decentralized AI applications.
And then Lachlan, do you have an analogy that you like to think about from the 0G lens?
Yeah, I think to make it, just as simple as possible, it's really important to move data around in Web3 as well as between Web2 and Web3. And, imagine a highway, we have traffic going each way with that traffic being data. We, in crypto, can get a lot higher throughput if we can keep adding highway lanes each way to move data at a much faster speed. And, it gets a bit more intricate than that because zero gravity also has built-in data storage, which, makes it even faster for people to get through that highway when there's a toll, for example. But yeah, I think that sort of simplifies it.
And I think a crucial concept for us all to understand is data availability. So continuing with Lachlan here, could you talk to us a little bit about first, what is data availability? And then why is it so crucial for blockchain networks and decentralized systems?
Yeah, so data availability is one of the biggest problems right now in crypto that's not actually talked about that much. And this all started with Ethereum, where there's just more and more people using Ethereum and it just wasn't scalable. So they introduced layer 2 blockchains like Optimism, Arbitrum, and there's just a lot more now. And these all do transactions off of Ethereum and then publish a cryptographic proof to Ethereum that essentially proves that these transactions were done correctly and honestly. But how can people on Ethereum that make sure everything's okay, so validators, how can they be sure these off-chain transactions were actually done correctly? And the way to do that is for them to have actually be able to verify the data that happened off of the blockchain. And that's the data availability problem. It's how can we have access to the correct data we need to verify stuff, and that could be layer 2 transactions, but there's actually a lot of use cases that go beyond layer 2 transactions that aren't possible right now because we don't have an efficient way to access data, let alone at massive scales. So to scale blockchain and the use cases, we need to be able to support these high performance use cases. And I'm not going to go into all of them, but in the context of AI, how can we access data sets on the blockchain at extremely fast speeds, let alone do all these computations and interact with all these different blockchains at the same time? Because we might have a data set on Polygon, we might have a data set on a different blockchain in the real world. And to run AI and to actually get all the benefits that Web3 can bring to AI, which we can touch on, but transparency, the ability for everyone to collaborate and build these new models, and much, much more. We really need a adequate system to verify this data on chain at high speed, low cost, and other beneficial characteristics.
Yeah, and you touched on some of the limitations. So let's talk a little bit about the existing limitations in the ecosystem, and then let's add on to that the limitations in AI, and then how zero gravity works to combat these and solve that problem.
Yeah, so zero gravity is not the first data availability solution. I think the first solution maybe started back in 2019, around that time. It might have been Celestia was the first one. But the landscape looked very different back then because things were evolving extremely quick. And although layer 2s were the primary use case back then, now we have all these other high performance use cases that I touched on. And, Ming, feel free to add on to this at the end, because obviously Ming's, CTO and, might have even more technical expertise here. But my understanding is that, first of all, with Celestia, which is a dominant player in the space right now, they have pretty limited throughput because all the nodes in the ecosystem have to talk to one another, which takes time, especially when you start scaling the amount of data. So they're limited to, I think, is it 10 megabytes per second, 10 Mbps. And they also started their code back in 2019. And my understanding from talking to several people inside and outside of zero gravity is that a lot of this code is actually outdated and needs to be updated, which will take a while. So throughput's a major consideration there. And then there's EigenDA, which is another great solution, but they have performance bottlenecks. For example, validators need to run a full Ethereum node, which has the entirety of the blockchain's history, and they need to interact with smart contracts on Ethereum, both of which slow down performance. And they don't have their own, really scalable storage system that's built in, which also affects performance, especially around stuff like decentralized machine learning, which is, as you can imagine, gets very complex very quickly. So, Ming, is there anything else to add there? That was my understanding.
Yes, I think it covers a lot of aspects, and I think another one is that for this data availability network in the EigenDA, actually, the network, the quorum. So we are also the quorum based solution. So the quorum in the EigenDA not selected from the leverage some security mechanisms in the Ethereum. So basically, in our case, actually, the quorum of the data availability actually selected based on a verifiable random function used in our blockchain system, and selected the quorum from the stakers, all the decentralized stakers from our network. So that could be more secure and really keep the majority honest assumption for this DA solution, which is very critical, I think.
Yeah, and let's talk a little bit about on-chain AI versus off-chain AI, because from what I know is that existing approaches, you store data off-chain, compute AI off-chain, and then verify on-chain. Talk to us a little bit, one, if that's the correct assumption, and two, like how Zero Gravity's approach really compares.
Right now, a common way to handle AI is to run the computations off-chain and then to bring the result on-chain and to do a zero-knowledge proof, which can essentially cryptographically prove that the calculations were done correctly off-chain and that nothing was tampered with and that you can trust the response. Now, that's good, but it's mostly dealing with like off-chain data, and that can be supported by Zero Gravity as well. But now with Zero Gravity, you can have access off-chain data and on-chain data, combine them as needed, combine data sets across different blockchains, and you can not right now, I believe it's on the roadmap, but be able to run all these computations on-chain as well with pretty cheap gas fees. So it's almost providing infrastructure to do this in a much more interoperable and on-chain way than only being restricted to doing off-chain and using a zero-knowledge proof, and getting the associated benefits from interoperability and different ecosystems tapping into one another. Is there anything to add to that, Ming?
Yes, I think it's very complete. Yeah.
Oh, amazing.
Well, we've got Lachlan as well as a genius. So let's talk a little bit about some of the core infrastructure of 0G. So people are probably imagining some of this in their head, but let's talk a little bit about the architecture. So talk to us a little bit about the like storage network, the data availability network, consensus network, and kind of how they all combine to a cohesive whole. So let's define each of those. And I'll direct it towards me.
Yeah. So, so 0G architecture takes a very modular design. So it has it has several loosely coupled components in the entire system. So the storage network, for example, it actually a collection of the decentralized storage node, which are connected through a gossip peer-to-peer network. And all these nodes then also connected to a separate consensus network in 0G. And so when data come into the system, and the real data will just get into directly passed into transferred into the specific storage node, and only the commitment or the root of the data will be submitted to the smart contract on the consensus on the 0G consensus network. And this smart contract actually used to coordinate the behavior of all the storage node in the sense of to give them the incentives, because these nodes are joined the network in a permissionless way. So it must need some incentive mechanism to let them work faithfully. And so it also takes some what do we call the proof of random access mechanism to verify the storage nodes that behave faithfully to store the data without any loss. So basically, yeah. So this smart contract will periodically select some random historical data in the system and ask the storage node to provide some proof of the access for that kind of data. And when this proof are submitted to the smart contract and got verified, and the corresponding reward will be distributed to the specific storage node. And this reward will come from the user paid fee when they upload data into the storage network. And they will also, at the same time, put some 0G tokens in our smart contract for this fee. And for the DA network, actually, it is behave similarly, but have different organizations in the network. So DA nodes are, as I mentioned before, are selected from the stakers in the 0G chain through the verifiable by using the verifiable random function to form a quorum, and this quorum have this majority honesty assumption. So most of the nodes will be assumed to behave honestly, and then the DA data will be split by another different mechanism to the different chunks and is uploaded to the specific DA nodes. And similarly, and it also needs this smart contract on the consensus to organize the behavior of the DA nodes. And for the serving network, it's also similar. We also use this smart contract to coordinate all these decentralized computation nodes to perform a collective valid tasks for the users. Yeah.
Amazing. And Lachlan, feel free to jump in and add any feedback. But if not, I will move directly into some of the intermediate concepts.
Yeah, I think you nailed it.
Perfect. So let's talk a little bit about data partitioning and infinite scalability, because these are two of the features that I think people are really excited about from Zero Gravity. So let's first start with data partitioning, because
Yes. So I think it's very important to make our system very scalable. And so the way to achieve this scalability is to employ all kinds of data partitioning scheme. So for different network, we have the different schemes of partitioning. So for the storage network, and our data on the storage network is actually organized as a log format. So basically, when the data come into the storage, and the data commitment will be submitted to the smart contract and logged in the smart contract as a log entry. So it is represented as a sequence of data in the system, and so in essence, we actually do not want the data for the storage node to broadcast and fully replicated among the entire network. So we basically like the storage node to decide which partition and the storage node wants to store the data, and then the storage node can tell the smart contract that okay, I just want to store this kind of this specific shard of data, so that you should query the data in this shard range, and also give me the incentive correspondingly. And so through this way, this sharding can be decided based on the capacity of the storage. For example, if the storage node do not have enough capacity to hold all the data in the entire system, so they can decide how to shard this data, and which shard and this storage node want to store. And also because we don't want all the storage node to store the same set of shard, and so we introduce some randomness to let them to come spread the shard in average in the system. So, and for the DA network, actually, we actually employ a Erasure coding mechanism to split the data, and so that the data will be split to multiple chunks before entering into the system, and each chunk will be put into a specific DA node, and there don't need to be any replications in the for the DA data, because the Erasure coding already provide the enough redundancy, and then the DA client will aggregate. So when this chunk is sent to the DA node, the DA node will verify whether this chunk is validity to belong to the specific original data, and the DA client will aggregate a majority of the signatures from the DA node to guarantee the capability to recover the original data for the system. And once it gets this multi signatures from the DA node, and it will then submit these signatures to the smart contract for record. Yeah. So this is how we partition the data for the DA network and the storage network. And for the consensus network, because the consensus network is a fully replicated system, so any data getting to the consensus network will be broadcast to all the nodes in the consensus network. So so that part actually eventually will become the bottleneck of the entire system, because every data getting to the storage node, getting to the storage network, for example, will involve at least a single transactions on the consensus network. So if we want to have this infinite scalability, we further need to scale out this consensus protocol. So the way we do that is that we also we try to employ multiple consensus networks in our system and treat each of them as a shard, And the problem is that how we can keep each consensus network as secure as enough, right? So that's we introduce a innovative mechanism called shared staking. So basically, we treat each of these consensus network as a AVS of these the eigenlayers restaking mechanism, so that every consensus network will be able to bridge its native token to the Ethereum to be mapped as a ERC20 form, and this ERC20 version of 0G token can further be staked into the eigenlayer restaking pool, and then this restaking pool will be treated as a shared staking, and every validators in the consensus network can use this restaked 0G token as their POS voting power. So we essentially use the same set of validators for all these kind of different consensus networks, and all these consensus networks share the staking status of all these validators, so that they share the same level of security. And we even through this way, we even can use the staked ETH as a capitals to protect the security of our POS protocol, so that we can get the Ethereum level security eventually. And you can understand that in this way, actually, we don't have the limitation of a number of consensus protocols, so it can be arbitrary number of consensus protocols participating in this system, so that we can have this infinite scalability in theory.
Yeah, and you touched on a few pieces there. So real quick, because we talked about shared staking and we talked about the infinite scalability, for people that are listening, talk to them a little bit about a specific example where this kind of infinite scalability is not only beneficial, but really essential for the future of Web3.
Yeah, so I think the requirements of this such scalability is mainly from our needs to support all kinds of different AI applications and also the layer 2 applications. So because our system is a shared platform, not for a single application, right? So we will have the capability to support the aggregated data loads that are required by all these kind of applications in our ecosystem. So So each of these applications will have the performance requirements range from tens of megabytes per second or even gigabytes per second. So I don't think currently there's a already existing system can support such kind of workload, such kind of can have such kind of big data bandwidth needs for these applications, for this application set. And because you can imagine that for this AI workloads, because currently the large language model is a representative workload for the AI computation, and the model size is already very huge, and it definitely will consume a huge numbers of a tremendous the data set to be to feed this computation, and and also the data engineering is a very important piece for this AI workflow, and a lot of data processing that will be required before the computation of this AI model. And so, yeah, I think that's demands how they drive this scalability design of a 0G system.
Absolutely. And earlier in the podcast, you mentioned proof of random access. Let's talk a little bit about what that even means and what does it enable within the 0G ecosystem.
Yeah, so basically, because we want to have, introduce this incentive mechanism for this storage node, and but of course we cannot verify every data in the system, because that will definitely become a bottleneck of the system. So we have to introduce this randomness, basically by sampling some historical pieces to verify whether a storage node will behave honestly. And once some malicious behavior detected, and they will lose this chance to get the corresponding reward. And so for the proof of so the system will randomly we will conduct this proof of random access in a specific period, and in every period it will randomly query some historical position in the sequence of the data to ask for the storage node to provide the corresponding proof. And this proof would be consume a lot of data bandwidth of the disk bandwidth to come up with a puzzle answer based on some cryptographics computation. And if this answer can be generated correctly and submit to the smart contract for verification, and then this storage node will have the chance to get this incentives correspondingly. And this is just similar to the scenario that, for example, in the class, and one teacher will randomly pick some students to answer some questions by name, and then the students that can answer the questions very well will make a better impression on the teachers. It abstracts the different chunks of data to into the multiple points in the polynomial, and then it recovers the data by providing some subset of these chunks, essentially the subset of these points in the polynomial, to recover all the points in the polynomial, to recover the entire polynomial, so that we can recover any points in the polynomial. So that's how they works to recover the data from the from the redundancy. And I think the good the advantage of this thing is to provide better security and also the better scalability for the data storage. Yeah.
Absolutely. And now let's go on to talking a little bit about lane separation, because I think this is going to be a new concept to many people. So let's talk about, what is data storage lane, and talk to us a little about these lane separations.
Yes. So because this scalability requirement, we actually don't want data to be get into this broadcast bottleneck. So, but if you want to provide this data availability guarantee, there must be some information that must need to be broadcast in some consensus network. So we try to minimize this part of data, so to minimize the broadcast bottleneck. So in that sense, actually, we separate the data types that need to be broadcast and don't need to be broadcast. So for the original data, we definitely don't need to broadcast because it is large and very costly to broadcast them. So that's why we introduced this partition mechanism to allow the data to be located on the specific nodes. But for the data root, for example, the commitment of the data, all the signatures, the multi-signature of the from the different DA nodes that requires the collective verification in the consensus network. So this is for the data publishing. So because the data publishing means that there must be some consensus quorum that will witness and verify the existence of data in the system. So that's why we have to broadcast this kind of data commitment and the signatures to the smart contract of the consensus network for the further verification. And I think this is this two-learn separation is mainly to minimize this broadcast bottleneck.
Amazing. Well, now let's move on to Michelle. We did not forget about you. Let's talk to you a little bit about Zero Gravity. They offer a high degree of customization. Talk to us a little bit about some of the customization that is available to developers and users.
Yeah, absolutely. So 0G, as you said, is highly customizable. And this is because we have a variety of different parameters that you can essentially adjust. So think of things like storage length, location, replication, how much of the network you're propagating to, so forth. And we also have this really unique idea of this aggregated DA. So essentially think of it as taking a data blob from an L1 or an L2, and then you have this aggregation of different DA layers. So as the end user, you can really choose what you want. So do you want to run on like high performance mode or high security mode or high reliability mode? It's really a choose your own adventure or choose your own configuration. And I think the emphasis here, I'm on the product side, is really thinking about the end user. So if you as the end user really care about 100% uptime, well, good news is that you can actually do this with this aggregated DA layer because you can choose more than one DA provider. So yeah, we really like this aggregated DA concept. It has a lot more customization and also because it's super collaborative and it helps us work together with other Web3 projects like DA layers in the industry.
Yeah, and let's talk about some of the use cases where this programmability really comes in. Specifically, I'm thinking about maybe AI, DeFi, or gaming.
Yeah, so right now we're still on testnet, but we do have a lot of interest from a variety of different partners already. Like you said, across different industries, a lot of different use cases, but I would say primarily on the AI and gaming side. So on the gaming side, we did recently launch a campaign with Blade Gaming. So they are a fully on-chain game studio that's built around WebAssembly and zkVM. And they have this trustless game engine called ZK Unity. And this is the first modular ZK game engine that really enables this real-time gameplay and trustless processes. And so what's really cool about ZK Unity is that they've integrated into 0G's DA layer. So this enables storage and verification of these ZK proofs on chain. And what's really exciting about this campaign, which I think ended earlier this month, is that within like 12 days, we had over 350,000 transactions on testnet. So that was a very exciting campaign. And then I would say on the AI side, one partnership to highlight is with a company called Aister. And we are essentially enabling them to bring small language models on chain. So this makes AI more efficient and accessible for everyone. And it's another effort that showcases, our developments to foster more of a community-owned ecosystem.
Yeah, and if you have like a specific increase or a specific benefit that really accrued to the strategic partners, would you mind sharing it?
Yeah, so I think there's a variety of different ones. Talus is one example. And I think, it's really just all about making previously impossible use cases possible on chain with our highly efficient and scalable DA layers and systems. So Talus, for example, we were able to bring their AI smart agents on chain. They're leveraging our storage system. And it really ensures that their smart agents can actually perform at their peak performance level. So that means faster model retrieval, lightning fast inference. We have a variety of different partners as well, which I won't go into all the weeds, but if you just go to our website, our blog particular that Lachlan helped write a lot of these posts, highlight a lot of these.
Absolutely. And let's talk a little bit about some of the performance increases. So we see about 1,000x performance over Ethereum dank sharding. We see 4x improvements over Solana Fire Dancer. Talk to us a little bit about some of the key factors that contribute to this performance boost.
Yeah, so the metric that we like to talk a lot about, which Ming has already done a really great job talking about this, so I'll be brief, but per consensus layer, we can achieve essentially 50,000 times the speeds of our competitors at 100 times the lower the cost. So we're basically finally able to bring Web3 to Web2 performance and cost parity. And so how we're able to do this is, we have, like we already mentioned a little bit about, we are segmenting the data into these data publishing and data storage lanes. So we're not broadcasting the data all the time across the network. So there's horizontal scaling here where every node added to the network actually adds to the overall bandwidth rather than being a bottleneck because of the scaling mechanism. So on our testnet, we have actually seen that each node has 10 megabytes per second, and this is each node. So if you have something like 5,000 nodes, that's 50,000 megabytes per second or 50 gigabytes per second. And this is all per custom consensus layer. So as Ming mentioned, you'll quickly see that the bottleneck actually quickly becomes the consensus layer. So right now, we're still using Cosmos as our consensus and Tendermint, but we will eventually have our custom consensus layer, like Ming said, with all these different multiple consensus layers. And you can think of this as adding additional AWS servers in the traditional Web2 context, where essentially you can just add another consensus layer for infinite throughput. So I think this is a really cool major unlock for the Web3 space and can lead to a lot of different new on-chain use cases like AI, gaming, like actual on-chain gaming, high-frequency trading, and so forth.
Yeah. So on that note, because it seems like a lot of exciting new use cases are getting opened up, talk to us what's next for 0G, zero gravity, and provide us with some like upcoming milestones or features that the community can look forward to.
Yeah, so a really exciting one is definitely our mainnet launch. So we are hoping to launch before the end of the year, and that means we will also have our own token. So very, very excited for that. Hope the community is very excited. And this also means that our DA and storage products will actually be readily available on mainnet, because right now we're just on testnet. And so what's really cool about that is that we'll be introducing, of course, with the mainnet launch, our 0G chain itself. And so I do expect many more partnerships and integrations with various dApps within our 0G chain, because we are also an L1. And I think I mentioned this a little bit before, but we're very collaborative. So, we really want to partner with not just Web3 projects, but also Web2, bringing Web2 use cases on chain and across a variety of different industries and use cases. So that's like the very exciting side on mainnet launch. And then Ming also mentioned a lot about the AI front. So on the AI side, we have a lot more that I would say that we'd want to do, and we're still pretty early on this. But as Ming mentioned, we are working on this decentralized AI serving platform. And so you can kind of think of this as a bridge that connects service providers and users. So on the supply side, you have the service providers that supply the models, inference, and training. And then on the demand side, you have the end users and consumers or retail users that actually want to use these models in an application like a chatbot. So we're basically creating this general framework for these service providers to run their AI models in a decentralized manner. But the ultimate goal is not just running these models, but to also train them in a decentralized way. So we're really excited about this product because it's going to get us one step closer to providing the necessary infra for all of these different AI projects and truly make what we like to say AI a public good for all.
Absolutely. And let's talk a little bit about for developers and projects looking at different DA solutions. And I know that 0G is obviously more than DA, but talk to us a little bit about why they should consider 0G as their top choice. And I'll start with Michelle and then I'll go around the table.
Yeah, sure. So I think that, right now we are focused a little bit more on the blockchain side because we are trying to get to mainnet launch and we have our token and so forth. But again, we are really trying to make AI a public good for all. So it's not just the DA piece, that's just one small component. We have storage, we have our 0G chain, and then we have this AI, operating system that we're trying to create as well. So it's a very ambitious project and mission and goal. And I think sitting at the intersection of both AI and blockchain is very exciting, and I hope for everyone. So yeah, I think we're really excited to see how both of these industries develop and how these two communities can come together and collaborate and co-create. So I really do think that collaborative nature hopefully is enticing to a lot of people, within various different industries.
Absolutely. I'll pass it over to Ming. I know you talked a lot about the technical aspects and why zero gravity is, of course, better than many of its competitors, but why should they make it their top choice in order to build here?
Just as we mentioned before, so basically, I think 0G actually provide a very scalable environment for the applications, and also we provide very well-designed interface and SDKs to allow the application to easily adapt into the decentralized environment. So I think that actually attracts a lot of developers and builders that have the same share the same vision, that want to democratize the AI workload to get into our platform. Yeah.
Perfect. And finally, Lachlan, give us the final pitch on why people should be building on 0G.
Yeah, there's an aspect of scalability, but I also think that the team at Zero Gravity is putting in a lot of effort to actually help builders succeed. And yeah, other ecosystems have that as well, but like this is a very fast-moving ecosystem with the top players already partnered, and there's a ton of potential in this space. So, if developers are looking for something that's actually going to have an impact and you want to increase their chances of success, I think Zero Gravity has a ton of potential right now. It's a great opportunity.
And we talked about a lot of technical topics today. Lachlan, we know you are an expert blog writer. Shout out where people can find some of the blogs so they can go a little deeper on some of these topics that we talked about today.
Yeah, if you go to 0G.ai, Zero Gravity's website, and you click on blog, the introduction piece introducing 0G, the starship, will give a great overview that concisely summarizes the architecture and why it matters. If you want to go deeper into actual components of the architecture, there's 0G storage and 0G DA, which are two other pieces that go into the storage system and the data availability system. I think those three topics give people a ton of knowledge that will really accelerate their learning as well. And they're pretty simple to follow along.
Absolutely. And Michelle, are there any resources that they should look at for maybe getting involved with the community?
Yeah, I would say definitely our website and the blog is a great place to start. But if you are a developer, check out our docs. We're actually revamping them right now. And then we are definitely around at pretty much all the conferences. Our CEO is traveling almost every week to go to these events. So definitely look out for us. We'd love to meet in person at an event. So yeah, just stay in touch and be in the Discord. We're very, very responsive.
Absolutely. So go to zero, and that is with a zero, g.ai, and check out. I will put all the links in the description real quick, just so everyone can keep in touch with you guys online.
Yeah, Lachlan, Alex, Todd. I just did a thread on Zero Gravity as well, so kind of breaks it down there.
Absolutely. And Ming, where can people find you online?
Oh, you can find me from the Twitter and also Telegram, and yeah.
Amazing. Michelle, do we have a Twitter?
Yes, it is Tian, Meeshtian.
Amazing. And I will put all of these in the description. So everyone go read the blog articles, go get engaged, and stay in touch with this podcast. Give it 5 stars, subscribe to it. And this is our final out.